So let's now move on to version number 4. So version number 4, the only difference is, given that we already got a complete contract using universal quantification and implication to cover the others unchanged portion of the postcondition. So now we know that using only a reference copy of the pre-state accounts is not satisfactory. So let's try. Do you think shallow copy might work? So let me draw a little bit connection for you. So you can see now we are trying to really put the different example we did previously together about the OIMP versus IMP, and also about the caching the values, whether it's a reference copy, shallow copy, or deep copy, right? We're putting everything together. Let's see version number 4. So we still have the same setup, except that it's version number 4. And then we have the same precondition and the same wrong implementation here, just the same as before. And we also got these two postconditions, which we already discussed when we talk about version 1 and 2. So now the only difference is we have now also we want to modify this others unchanged postcondition a little bit. So the only difference is now we say rather than old accounts in the previous version, we say all accounts.twin. So now what we have to cache in the pre-state will be a shallow copy of the accounts array. Hopefully you can see that difference. Everything else, the logical patterns stay the same. So let's trace it very quickly. So now before I try to trace it, you may want to pause the video and think about, is this shallow copy enough to really make sure we can really see the difference between the pre-state account for bill and also the post-state account for bill? Okay, that's really the question for you to think about. Okay, so now let's continue. So what I would do is, again, we are trying to execute this particular feature over here to deposit Steve, and then after we have executed the precondition, which is satisfied, so now in the pre-state over here, we are now going to do caching. Okay, so now we're going to do cache. What should we cache? So the iPhone compiler is going to look at the postcondition. Again, these two have been discussed already, so they are not omitted. So now what we should cache is about the O expression. The only O expression is over here, and it covers this particular twin, which is a shallow copy of the accounts array. That's all we gotta cache. So under the hood, we're going to create, like an iPhone compiler, this temporary variable old accounts twin. Okay, now it's going to point to a shallow copy of the accounts array. How do we create a shallow copy of the array? We have done that already, so let's do it now. So this is the array that we want to make a shallow copy of. So what we'll do is a shallow copy of the array. First of all, we're going to create a new array over here, also with index 0 and 1. And now for each index over here, for example, let's say just temp. This is a shallow copy, right? Just temp array. So now the shallow copy, the temp array, 0 over here should be assigned to b.accounts at position 0, right? Remember, for shallow copy, it's going to be a reference copy starting from the first level. So only a reference copy. And similarly, we're going to do for position 1 as well in a similar manner. Okay, that's how we're going to do the shallow copy. Okay, so these two are rather simple. You just change the pointers, basically, right? First of all, this 0 over here is now going to point to wherever accounts 0 over here is pointing to, right? So now you can see that. So these are really aliased over here and over here. Okay, let's do another one. What about the second element? Let me use a different color. The second element is the blue. So now this position, the second one is also going to point to the second one without creating a new account objects. Again, to really show you the aliasing, you can see here and also here. So they're aliased from the first level of the attributes. And then the twin copy over here should really point to this new array. Of course, you can think about this temp might be garbage collected later on. Okay, so that's about creating the cache version of the pre-states. So now let's say we go ahead and we try to execute the wrong implementation, which is going to update Steve to 100. That one's correct, but we are also going to update bill to be 100 as well. Okay, hopefully from the diagram you can already see whether the shallow copy is going to be satisfactory or not. Let's see this. So now we get to the post state over here. So post states. And then we're going to evaluate this particular logical expression here. Again, we're going across this particular pre-state value, which means we are using this cache value, cache variable to use to go over, right? So now when we go over that, the first iteration, let me just do a little bit preview. When we go across this particular version of the pre-states, there are going to be there are going to be 2 iterations because the size is 2. The first iteration, we're going to look at this particular account. And the second iteration, we're going to look at this particular account. You can see we are really looking at the same account as the original array, right? For example, over here, they are really referring to the same, just for the first iteration. So now let's see this. Let's try to trace it. For the very first iteration, what's going to happen? For the first iteration, we are going to look at index 0. So that's referring to this particular account's objects, where the owner is simply just Bill. Okay, so ACC.owner is Bill. And then ACC.owner is Bill, similar to what we did before. And then the n over here, again, is Steve over here, right? So that should be n is Steve. So now, Bill not equal to Steve should be true for the implication. Similar as before. So now it's reduced to this particular consequence to evaluate. Should this be true or false? Let's try. ACC refers to the pre-state version that we just circled over here. And what about over here? When we say current, that's a post-state, right? Current is really the post-state value for this bank. And current the account of by calling the query on the bill. So this is going to return back to us the same, actually, the same account objects. So we are, after all, we're still referring to the same objects. So are they the same? Apparently they are, because they are the same objects for the account for bill with the wrong balance 100. So this particular equality over here is going to give you true. So we end up having true implies true, which is still true. So for the very first iteration, it's going to give you true. Okay, and then for the second iteration, it's going to be straightforward, because for second iteration, we're going to look at this particular account, right? Because now it's actually pointing to by the second position of the caching version, right? So now if we do it, so now ACC, the owner, should now be Steve. And then n, also Steve, that's the input. Steve not equal to Steve should be false. So the antecedent is actually false. That means the whole implication should just be reduced to true. So now you can see the first iteration is true, and the second iteration is also true. So the universal quantification that we have over here is actually still true. What does that mean? That means the current postcondition we have revised still cannot catch the error. It will still be considered as satisfying, okay? Which is not good, okay? What we really expect to see is we want to have a good postcondition such that it is able to cause a violation, to cause the error that we have over here. That's really what we want. That's what we would like to see eventually. Okay, let me go back to the slides and show you that. Okay, so now if you try that over here for version number 4, you will only see that no postcondition violation will occur when you call this feature over here. You only see this particular assertion will actually be false because Bill's balance has been unexpectedly modified to 100. So you will still see that for version number 4, no contract violation has occurred, but your customer is very unhappy. The supply is not being blamed. Okay. Finally, let's look at version 5 very quickly. So now hopefully you can see why eventually when we get to version 5, why can it solve the problem. Okay, the same as before, the same setup, the same precondition, the same implementation, that's wrong. And now we're going to say old accounts.deep twin instead. So now we're going to make a deep copy of the pre-state value for accounts. Okay, this, I claim that this is going to work. And the logical pattern stays the same, right? Why is this going to work? For completeness, let's trace very quickly for your own learning. Okay. So now, again, we're going to trace in this way, right? So after checking the precondition, so now we are in the pre-states. Before we execute the implementation, we have to cache. So pre-state over here. So now, how do we cache over here? Again, we omit this part here. It's been discussed. When we try to cache this part here, for compiler will look at the old expression, which is only, this is the only occurrence. So that's going to be the old keyword covering this particular expression over here, right? Just make it larger for you, okay? So now, what does it really mean? That means we're going to cache this particular expression. So now, under the hood, we're going to get old accounts deep twin. Okay, that is assigned to accounts dot deep twin. Okay, if that's the case, so now how do we create this deep copy? We also visualized that in the previous exercise, but let's do that quickly. So now what we're going to do is we're going to do a deep copy for the accounts array. First of all, let's create a new accounts array, which is just the same first step as a shallow copy. So now 0 and 1, and then let's say this is simply just temp. Okay, eventually it will be garbage collected eventually. So now, how do we assign the member for each one of them? Okay, according to the definition for deep twin, what we should do is as follows. Let me just write it down. According to that, so now if you got the temp, which is a deep copy, at position 0, which is referring to here, okay, should be assigned to, this is the array that we are trying to deep copy in the pre-states. So it's going to be b.accounts at position 0 dot deep twin. Okay, recursively, remember, it has to call the deep twin recursively. And also for position 1, that's also going to be assigned to another deep copy for different elements. So accounts at position 1 dot deep twin. So what's going to happen is we are just, instead of just referring to the same as before in the shallow copy, we will have to actually create new accounts. Let me put it here. So we have to create one new account over here. That's a deep copy of this account over here. So it's going to be owner and also balance. The owner should be Bill. I would say B over here. And then the balance should be 0, right? And then position 0 should point to this new copy here. And then for the second one, we're going to create a deep copy for this. So we create the account objects here, accounts. So we have owner, which is Steve, right? Steve, and also balance should be 0. And then position 1 is now pointing to this particular accounts. So that's a deep copy. And then finally, we have to make sure we assign, right? We assign this cache variable to point to this particular deep copy array. And then, of course, we might discard this temporary variable for the deep copy. Okay, that's basically what has happened for the caching process. And now let's try to do the rest. When we execute this wrong implementation here, first of all, we're going to deposit 100 into Steve correctly. However, the second part, we're going to also deposit into Bill wrongly. Okay, so now hopefully you can see now the advantage of using deep twin in this case is now the pre-state that we cached has nothing to do or independence from the post states. So now we can really compare them and contrast them for differences. So now let's see when we actually reach this part here for comparison. Okay, let's see the two different iterations. So now we're going to go across the old version of accounts.deep twin. So in order to evaluate this particular expression over here, as I said before, we're going to look at this under the hood cache variable, which refers to this particular array. So we're going to have two iterations. Let's look at each one of them. For iteration number 1, we're going to see this particular account. Agree? That's iteration number 1. So now ACC, the owner, is simply just Bill. And as usual, N over here should just be the Steve that we pass as arguments. So N over here should be Steve. Okay, again, Bill not equal to Steve should be true. So that means this part here would just be true, making the implication be reduced to this particular Boolean expression to check. So now what's ACC? ACC is this particular blue account over here, the blue one. And then what about the post date? The post date still is this particular bank, but now when we say this particular post date bank, the account of ACC, the owner, is actually Bill, right? Just don't forget, it's actually Bill. So now, what about the pink objects? So now be careful. So now when we search for the account of the current, so we're searching from here. So that means we are referring to this particular Bill account. So you can see the blue and the pink, they are now referring to independent object structure. So now if you compare the blue one over here with balance 0 in the pre-states, and the pink one over here with the post-date 100 over here, right? So now, are they the same? No, they are not. They are not the same, because remember, equality over here for accounts means the balance should be the same. So now, let me just highlight it. So now that means this particular equality will give you false. So eventually, what you will get is false for the first iteration. So what about the second iteration? In some way, it doesn't matter anymore, because for universal quantification, as soon as you get the first false, overall it's going to be false. But just for completeness, let's just trace that anyway. So now, in order to do the second iteration, so now for the second iteration, so we're going to look at just this accounts over here, right? Just here. ACC, the owner, is Steve. N is Steve. Steve not equal to Steve should be false, making the whole implication here to be true, right? According to the theorem that we talked about. So now we got false and we got true. So for universal quantification, it should be false overall, right? Let me highlight it for you. So now we are really talking about this particular post condition over here that we introduced using a deep copy of the post states. So now it's going to give us back false. And the false, let me just write down the interpretation over here. This is appropriate. Because we know that, okay, let me just recap again, okay, as we said previously. Here we got wrong implementation. Wrong implementation implies we actually get post-condition violation. Post-condition violation. Every time if there's anything that goes wrong, you should always have one party of the contract to be blamed. In this case, the post-condition should be violated, so we can blame the supplier for not implementing their implementation correctly. Okay, so hopefully you can really see how each version, from version 1 to version 5, how they actually work together, right? And eventually we get this version 5. And the reason that we have to use deep copy unavoidably, just because the change that we made maliciously over here on build over here is beyond the first level. It's almost like if you check in your previous part of the lecture, when we actually just try to append to the mark string by star star star, that's exactly the kind of change we are trying to make over here. Okay, let me just conclude this lecture here quickly. So now for this version here, eventually when we try this, so now when we upon the completion of executing this feature over here, we will get a post-condition violation. So now we will not even get to here, which is good. So now before the client has to check whether the result is satisfactory or not, we actually get a post-condition to blame, post-condition violation to blame the supplier. Okay, so now this is really desirable. So now eventually we get post-condition violation. So this is expected. So you can see we got all the results from all the previous 5 versions, all the 4 versions, and also the current version. Okay, so now I will suggest you really try to download the source code for these 5 versions over here. So you can click on the link, and then you can unzip the IFO project and then reproduce what we have done. So really, it's really important for you to understand both conceptually how every version work, and also to try them out in IFO Studio. Especially, I encourage you to actually look at the debugger to see how the shallow copy, reference copy, and deep copies, how are they made in this context. Okay, to beyond this lecture here, I would suggest you do the following exercise. Okay, let's say we have another. Oh, actually, this is the query that we talk about, which is account of, right? It simply return the account object for the corresponding name. So now, how do we specify as part of its post condition to say, for this particular account of, we do not mean to change the accounts array. We don't really mean to change that. So what could be the corresponding post condition that we should write that's complete, right? We want to write a post condition such that if there's any wrong implementation that try to modify the array, in that case, we should give a post condition violation. So in the slides, I already gave you the answer, but I would suggest maybe not to look at the slides. If you have looked at that, maybe cover the answer, okay? What I would like you to do is, you can go to the iPad notes over here. I cover the answer over here, right? So these are all the possible, some of the most common possible post condition you might write in order to assert that. So what we really want to assert is to assert that the state of the bank remains unchanged. Specifically, we don't want the accounts array to be changed. So we got this many versions for you. So you want to consider which one or which ones are correct or incorrect. That's something as a self-assessment for you that I will encourage you to really try. Okay. So it's been quite a long story to tell about how we can do object copying and also write post condition, but it's a very fundamental part for learning design by contract. That's why the lecture has been longer than usual, but I think it's worth for you to spend the time to really understand every part that's been broken down for you.